Hello everyone, my name is Prajwal and today I will be talking about Bohr models versus Lewis models. So what is a Bohr model? A Bohr model is a type of diagram which shows all the different parts of an atom in an element. For example, for the element oxygen, you put in the element symbol, which is O, and then you put in the number of protons and the number of neutrons in the middle. And then you put in electron shells. The first shell contains a maximum of 2 electrons, and you pair them up like that. The second shell and the third shell contain a maximum of 8 electrons. When you're placing the electrons, you have to place them in a circular motion, and you place 4 of them, and then when you run out of the spots, you have to pair them up. And the fourth shell contains a maximum of 18 electrons. In the middle is the atom's nucleus. You can get the mass number by adding up the protons and the neutrons. And then on the outside are the electron shells. As I said, they can contain a maximum of 2, 8, or 18 electrons. Bohr models can also be used to show ionic bonding. Ionic bonding is when a metal and a non-metal combine together to create a compound. For example, here is sodium and chlorine. Usually, all atoms like to have full valence shells. The valence shell is the outermost shell of each atom. For example, sodium has 1 extra electron, and chlorine is missing 1 electron. So what happens is that the sodium will give away or donate its electron to chlorine, so that sodium and chlorine can both have a full valence shell. So what ends up happening is you have 2 ions, a positively charged sodium and a negatively charged chlorine, because an electron is negatively charged. And they are still attracted to each other because opposites attract. So this is what happens in ionic bonding, and you can show it with Bohr models. Here's another example of an ionic compound. Try and pause the video to figure out how to make the Bohr models, and then make the ions have their full valence shells. Okay, let's get started. I already drew the Bohr models. Here they are, and each atom has the same number of electrons as its protons, because for atoms to be stable and be neutral, there needs to be the same number of electrons as protons to cancel the charge. Right now, magnesium has 2 valence electrons, and fluorine each needs 1. So what magnesium can do is it can donate 1 electron to each fluorine to form magnesium fluoride, which is MgF2. And when you draw out all of the ions, this is what you will get. You will get the 2 fluorines with their extra electron, and then you have the magnesium without its valence shell. And you would put the brackets and the charge on the top right to show that it's an ion. Bohr models can also be used for covalent compounds. Covalent compounds have only nonmetals that share the electrons in their valence shells. A famous example is water. For example, the hydrogen and the oxygen are sharing the electrons, as if they had it for themselves. You may have noticed that there is a pattern. In both covalent and ionic, only the valence electrons are being affected. The protons aren't changing. The atom symbol isn't changing. The inner electrons, these shells, are not changing. So, I wonder if there is a better way to show covalent and ionic compounds without even drawing these parts. Luckily, it exists. It's called the Lewis dot diagram. Let's go over the sodium chloride compound that we did using the Bohr models and use the Lewis dot diagram instead. All we need to do is put the element symbols and then put the valence electrons as dots. That's it. And then if we want to show the ions, we just put them in brackets and then only put the valence electrons. Just like this. Very simple, right? Now let's do the same thing, but with magnesium and fluorine. Pause and try to figure out how you can do this with the Lewis dot diagram. Okay, let's get started. First, we draw the symbols, which I've already put, and then we put all the valence electrons. Fluorine needs 1 electron while magnesium has 2 extra. So magnesium can donate its electrons to fluorine, which results in this. If you look at both the Bohr model and the Lewis model side by side, you will immediately notice a difference. The Bohr model shows everything about every atom. Its protons, its neutrons, its inner electron shells, while the Lewis dot model is more minimalistic and only shows what exactly happens during the bonding process of ionic or covalent. The Lewis dot model is actually more useful for covalent compounds than the Bohr model. Let's revisit our water. First we draw the hydrogen and the oxygen. Next we draw the valence electrons. Oxygen has 6 valence electrons while hydrogen has 1 each. And then to show that they are being shared, we draw a circle between them. These over here are lone electrons. And these are lone pairs of electrons. Now to finish up this drawing, all we need to do is replace the circle with a line. Like this. Don't forget to put the lone pairs too. And there you go. Here's your water. Both the Bohr model and the Lewis dot model can be used in ionic and covalent compounds. But in my opinion, I think the Lewis dot model is the best because it is simple and it shows exactly what's going on and doesn't have lots of cluttered information. But if you want to display everything about an atom, then you can use the Bohr model. If not, then you can use the Lewis dot model. Thank you for watching my video.